In our previous video, we learned about the family of circles through the combination of a circle and a straight line. Today, we'll be looking into the family of circles through the combination of two circles. Let's take these two circles S1 whose equation is x squared plus y squared plus 2g1x plus 2f1y plus c1 equals 0, and S2 whose equation is x squared plus y squared plus 2g2x plus 2f2y plus c2 equals 0. Now consider the equation S1 plus lambda S2 equals 0, where lambda is a parameter. When we substitute these equations, we get x squared plus y squared plus 2g1x plus 2f1y plus c1 plus lambda into x squared plus y squared plus 2g2x plus 2f2y plus c2 equals 0. Now we'll open the brackets and rearrange it. Then we will get 1 plus lambda into x squared plus 1 plus lambda into y squared plus 2 into g1 plus lambda g2 into x plus 2 into f1 plus lambda f2 into y plus c1 plus lambda c2 equals 0. So now this equation has equal x squared and y squared coefficients, and there are no xy products. So this is an equation of a circle. So as lambda varies, we get a family of circles. So the family of circles formed by the combination of two circles is given by S1 plus lambda S2 equals 0. However, it is important to state here that lambda cannot be equal to -1, because then the coefficients of x squared and y squared become 0. Then we won't have the equation of a circle. So let's consider the two situations of the family of circles. Here we have the first situation when the two circles intersect each other. Here we have two parent black circles. The brown circles represent the family of circles. So when the two parent circles intersect each other at points P1 and P2, their family of circles will also have one common characteristic. All the circles will pass through the same points of intersection of the two parent circles. So here all the circles will pass through the points P1 and P2. So when two circles intersect each other, the family of circles will pass through the points of intersection. Now let's go into a second situation. So here we have when the two circles touch each other. In this situation also the family of circles will have one common characteristic. They will all pass through the same point of contact of the two parent circles. In this case, all the circles will pass through the point P. So when the two circles touch each other, the family of circles will pass through the same point of contact. So those are the only two situations of the family of circles. You might be wondering, what if the two circles do not touch or intersect each other? Well, we don't have a family of circles when the two circles do not touch or intersect. In this situation, the formula S1 plus lambda S2 equals 0 does not yield any equation of a circle. So we have only the above two situations mentioned before. So to understand this concept better, let's try a question. So here it is given that the circles S1 x squared plus y squared minus 1 equals 0 and x2 x squared plus y squared minus 4y minus 5 equals 0 touch each other. We are asked to find the equation of the circle S3 which passes through the point of contact and A minus 2 minus 3. Since this circle S3 passes the point of contact, we can understand that it is part of the family of circles. So we can use the equation S1 plus lambda S2 equals 0, where lambda is a parameter. So that would give us x squared plus y squared minus 1 plus lambda into x squared plus y squared minus 4y minus 5 equals 0. Now we need to find the lambda value of S3. To do this, we have to make use of the only other information given to us about S3. It is told that the circle S3 passes through the point a minus 2 minus 3. So, a minus 2 minus 3 will satisfy the above equation. So, when we substitute these values into our equation, we get minus 2 squared plus minus 3 squared minus 1 plus lambda into minus 2 squared plus minus 3 squared minus 4 into minus 3 minus 5 equals 0. Finally, we can get the lambda value of S3 as minus 3 upon 5. So now that we have the lambda value, we can substitute this into our initial equation. So when we substitute minus 3 upon 5 into this equation, we will finally get the equation of S3 as x squared plus y squared plus 6y plus 5 equals 0. So now you understand how the family of circle concept works. Next, we move on to our tip of the day. Previously, I mentioned that lambda cannot be equal to minus 1. So let's see what happens when we substitute minus 1 into this equation. So that will be 2 into g1 minus g2 into x plus 2 into f1 minus f2 into y. There should be a y here, plus c1 minus c2 equals 0. This equation is quite familiar. You have learnt about this in our previous video. Try finding it out. If you can't remember, let's substitute lambda equals minus 1 into the equation s1 plus lambda s2 equals 0. We get s1 minus s2 equals 0. Now you definitely remember this equation. It is the equation of the common chord or common tangent of the two circles. So when lambda equals minus 1, we get the equation of the common chord and not a circle. So that's all for today's video. Comment down below if you have any questions. Until we meet again, take care.